Assalamu alaikum class. Good morning. This is Mr. Wadikowa taking you in Paper 1 Physics. And in the studio we have Mr. Silvamba Suman. So today we are still looking at projectiles. Projectiles. Last time, if you can recall, we defined a projectile as a particle which is given an initial velocity and is left to move on its own. So if you project a stone, if you kick a ball, you are giving it energy. So as you give it energy, you leave it to move. As it moves, it acquires potential energy. When you are releasing it, it has kinetic energy. But since it's moving on its own under the influence of gravity, that particle is referred to as a projectile. So if you can try to describe the path of the particle, at this point, this is the initial point of projection. As you release that particle will take automatically the upward motion. So it's going to move on its own under the influence of gravity up a point when it lands on the ground. So this path taken is always a smooth curve. Why is it smooth? It is smooth because at every point the gravitational force is constant. And that gravitational force will always act in vertical direction, but to act downwards. And therefore, it makes that curve to be smooth, which in fact as it is parabolic. So at a given point, which is the maximum height, we realize that the particle, by all means, it must move downwards. So at that point, what happens is that the velocity, which is the final velocity given, is equal to 0. So at this point, we are referring this point as the greatest height, which is h, maximum attained by the particle. And at the beginning, the particle was given initial velocity, which is u meters per second. And remember, as you are projecting the particle, you are projecting it at an angle theta to the horizontal ground. So as it moves, it is covering x meters along the horizontal axis. At the same time, it covers y meters along the vertical axis. So at a certain point P, this P, along the parabolic path, which in fact as the trajectory, at the point P, it has covered x, at the same time y. And that means this one here, the particle is y, and horizontal is x. So we have the y and the x. Y and x. So anyway, this is what you can see very well. This is x meters at this point. And this is y meters covered this way, vertically upwards. So when the particle is here, it has covered x meters and y meters vertically upwards. So at this point, P, this P, in terms of coordinates, is capital X, which is horizontally covered, and capital Y, which is the distance covered vertically upwards. But the particle has to continue up to when it lands on the ground. So last time we covered H maximum. How you can get H maximum? We had that expression. And we have that expression of H maximum. We looked at time to reach maximum height. This time, we are going to look at the expression for the time of flight. Time of flight. What is time of flight? Time of flight is the time taken by the particle to traverse the trajectory path. Is the time taken by the particle to move from the point of projection to the point where it lands on the ground. Is the time taken for a plane to leave certain point? We can assume maybe this is Entebbe airport and you are going to Cairo or Bangkok. Then the time it takes to leave Entebbe airport, that time, okay, it takes to leave Entebbe airport, and the time it takes to land Bangkok, that time is not the time of flight. And that's when the plane have had a flight. So you can only visualize when the plane lands on the ground. Then you can claim I had a flight. And therefore the time between the point of projection, the initial point of projection, and when it lands on the ground is what refers to time of flight. Therefore, the time of flight, we can only confirm that you have had a flight when the plane is on the ground. And therefore, at this point, H must be 0. Because remember, as you are progressing, the H keep on increasing, okay? The height keep on increasing up to some point when H becomes maximum. They start progressing downwards because the final velocity at that point is equal to 0. As you progress downwards, H keep on decreasing until when H becomes 0. And when the H is 0, we shall confirm that you now are on the ground. Even if you take an example of a ball, you kick a ball from one goalpost, that was going to progress in that direction. It reaches at any point when H is maximum and V becomes 0, then it's going to progress up to the other goalpost. And when it lands on the ground, then we shall claim the time taken by that ball from the point of projection where it lands on the ground is referred to as the time of flight. And how do we get time of flight? It means we get time of flight based on two concepts. One, the ball, the plane, the particle must be on the ground. That's number one. And therefore, the formula I'm going to use must include the height. Must have the height. So, that formula which I'm going to use must have time. And remember, we have three formulae which we apply as far as motion is concerned. I repeat, we have three formulae which we normally apply as far as motion is concerned. The first formula we can apply here is when you talk about V is equal to U sin theta minus gt. This is number one. The first formula we apply is V is equal to U sin theta minus dt. We looked at how this formula is obtained. And we do that formula by modifying our initial velocity as U sin theta, because this ball happened to move in the vertical direction. Then the d, initially it was referred to as A, but now it's negative g. Why negative? Our acceleration due to gravity is g. And since the particle is moving upwards, it is opposing the gravitational pull. And therefore, we put a negative in front of the g to imply that it was opposing gravity. The second equation which also modified, remember, it was S, where the particle is moving along the horizontal surface. But here we are claiming the particle is covering some height. So we shall never talk about S. S is when the particle is moving along the horizontal surface. Now the particle is moving upwards at an angle theta. So our S now becomes H. At every point, the particle is covering certain height. So S becomes H. And the H was equal to U sin theta times T minus a half dt squared, which I'm sure you understood very well in our previous work. This we had this review. So at this point, we are still also providing this squared is equal to U squared sin squared theta minus 2 dh as our equation number 3. And basically, as far as motion is concerned, we have 3 main equations we use. This is referred to as the first field of motion. This is the second equation of motion minus a half dt equal to 0. Then you go ahead to get the capital T. And this is what I imply that this is a half dt is equal to U sin theta. U sin theta. Then our target is to make T the surrogate. So first multiply by 2 left and right. I will get automatically, I will get dt is equal to 2 U sin theta. And finally, divide through by g. Divided by g, divided by g. That gives us t is equal to 2 U sin theta divided by what? By g. Plus, what you're writing now is what we refer as the expression for the time of flight. This capital T is the expression for time of flight. And therefore, if you want the time of flight for a particle traversing trajectory, you must have the initial velocity, which is this. You must have an angle of projection, which is this theta. And the g is always a constant value. G is always constant, and in physics, our g is very clear, it's 9.81. And therefore, topic time of flight, I'll just need to have the initial velocity, which is here. Get the angle of theta, which must be given, and g is the constant. So that will automatically help us calculate the time of flight. So that's what I'll get time of flight. Time of flight. Let us have an example to see how we can apply our formula to get time of flight. So since you have this, let us have an example where time of flight is required. For example, write this example as an example, and writing a particle is projected with an initial speed of 20 meters per second. A particle is projected with an initial speed of 20 meters per second. With an angle of projection 30 degrees to horizontal. With an angle of projection of 30 degrees to the horizontal. Taking G to be 9.81, taking G to be 9.81, calculate. Taking G to be 9.81, calculate the time of flight. Calculate the time of flight. So this is what we are, this is what we are writing, a particle. A particle is projected. Is projected with a speed of 20 meters per second at the angle of projection of 30 degrees. The horizontal. Calculate. The time of flight. Take a jet to be 9.81 meters per second squared. That's the example which I gave you, which you can now handle. So this is what we have. A particle is projected with a speed of 20 meters per second at an angle of projection of 30 degrees to the horizon. Calculate the time of flight. Take a G to be 9.81 meters per second squared. So when you are answering any question in physics, it is a must that you must first extract the numerical data. You extract the key ideas. Then you can write solution, and then you let us know what is given to you. So it's a given. By writing this one, by giving us the information which is given in the question, it means you have understood whatever it takes. So first of all, you have to sketch. You have to sketch. And if you are sketching, then you let us know that this is U was given, this arm is also given. So U is given. What is my U? My U is given as 20 meters per second. My arm is given 30 degrees. Then these are the two key ideas you have. So sketch means you have understood that given equation. So that means I have U as 20 meters per second. My angle of theta is 30 degrees. G 9.81. 10.81. So what is required? What is required? Time of flight. So time of flight T, which we have just obtained, is given by 2u sin theta divided by g. So now what it means is just to substitute for the given variables. G is given, G is 20. The angle is given, the angle is that. G is known, 90.81. And these are meters per second squared. What does it mean? It's an acceleration. And those are the SI unit for acceleration. Degrees, small not, meters per second, SI is for velocity. So the first mark that you can get will be for recalling, giving us this expression. We shall award you 1 mark for being intelligent. But still, you can also give us a t. You can get the value of t using the first principles. But if you have this expression, just t is equal to u sin theta of, which means my t is equal to 2 times my u is given as 20 meters per second. 2 times 20 times sine of theta, which is sine of that, divided by g. This is 9.81. But what we have this g? G depends on the person setting. That's what you have. I can say this will be 10 meters per second squared. So don't round the gain so that g must be 9.1. It can be 9.8. So that g will always be provided for you. So don't get what I'm saying, start thinking about what about 9.8, what about 10. When we give you 10, use 10. When we give you 9.8, 1 is 9.81. And if you give 9.8, take that one. It depends on the situation. So when you look at what is given, it's now simple arithmetic. Those who calculate, I'm sure you have the answer. You get a sine of 30. Sine of 30 in your calculator is going to give you 0.5. So this is 2 times 20, which is 40. Times sine of 30 is 0.5. Divided by 9.81. And at your level, don't expect to give you the answer because that must be known in this one. But 40 times 0.5 is 20. Take by the 9.81. You get 20 by 9.81. And finally, what we get from this arithmetic will be automatically in seconds. Not in seconds. So you get 20 by 9.81, and finally what you get will be in seconds. And that one becomes time of flight. So we have more examples, but I'm sure in this example here, you have understood how time of flight can be obtained as far as a projectile is concerned. And we say a projectile is any particle which is thrown, which is given initial velocity, and it's left to move on its own until it lands on the ground. So it means it can be a ball, it can be a plane flying, it can be a storm, so long as it's given kinetic energy, which in fact has initial velocity, and it's left to move under the influence of gravity. That's called a projectile. Meanwhile, at a given time of flight, it brings us to what we refer as the range. So now it means we are moving now to the horizontal range. And last time I want you to recall, we defined the horizontal range. But what happens when you project a particle, if a particle is projected at an angle of the hologram, you are giving that particle energy, but the angle is realized as theta, and this is u, meters per second. As it moves, it covers h maximum. H maximum. But look at this one. From the point of projection up to the point where it lands, it covers a horizontal distance. Much as the particle is taking the vertical direction, but at the same time it covers a horizontal distance. And that distance is referred to as the range given by the capital R. So we want to get an expression for the range. But before we get that expression for the range, what is the range? What is understood by the term range as far as vision is concerned? Like we define capital H as the greatest height reached by the particle above the ground. The given range can also be defined as the maximum horizontal distance moved by the particle from the point of projection to the points where it lands in the same plane. It is the maximum horizontal distance moved by the particle from the point of velocity. We have the vertical component, which is Vy, and Vy was equal to u sin theta. You can call this. And I had Vx, which is u cos theta. And from the beginning, I was very clear that as long as we talk about vertical direction, this is the velocity used. If the particle is moving in vertical direction, this is the velocity used. And when the particle is moving in horizontal direction, this is the component of the speed. This is the component of the velocity we use. And since range is horizontal distance, the speed we are referring to is u cos. All the three divisions of motion, the particle, there is a distance covered along with the ground, and that distance is what we refer to as the range. And the range being the horizontal distance, we shall use this component. So our speed becomes u cos theta times. And if you look at this is moved horizontal at this point, the time of flight. So I'm going to use the speed as the horizontal component of velocity, which is u cos theta, and my time of flight. And that gives us the range. But remember, the time of flight is given by 2 u sin theta over d. Which means my hour is equal to u cos theta times time of flight, which you have in your notes. That's time of flight. So here. Manipulating this one here, we shall end up with range. Range R is equal to 2u. When we multiply class u times u, that gives us u squared. U squared. That means we're going to have 2 u squared. Bring the cos theta times sin theta divided by d. If you can reach that level, then for us to claim this is the expression for the horizontal range. R means horizontal range. So as long as you can achieve this, that means you have obtained the range R. But from trigonometry, I'm sure my students of sample math and principal mathematics, and you cover trigonometry. And if you cover trigonometry, it's very clear that sin 2 theta means 2 cos theta sin theta. As well, you can begin with the signs. Okay, this is multiplication, so this is acceptable. So sin 2 theta is equal to 2 cos theta sin theta. I can simplify this expression by extracting 2 cos theta sin theta. I repeat, I'm now looking at 2 cos theta sin theta as sin 2 theta. And therefore, that means range can be written as u squared sin 2 theta over g. So the two means the same. This is either r can be this or can be that. These expressions you are obtaining have the same meaning. So that means to get the result already moved by the part, by the form, by the plane, okay? By a projectile. You just have to have initial velocity. You must have the angle of projection, and finally, g is the constant. And that gives us the range. That gives us the range. Let's take an example. Where do we apply this formula? Let's have an example and solve an apply this formula. So our example is basically going to address how we can utilize this formula. An example we are having a particle, we are writing a particle is projected, with an initial speed of 40 meters per second. A particle is projected with an initial speed of 40 meters per second. With an angle projection, 30 degrees. Calculate the horizontal range covered by the particle. Calculate the horizontal range covered by the particle. Take g to be 10 meters per second squared. This is the question. A particle is projected with an initial speed, can even call it initial velocity, of 40 meters per second. At any angle, this is what I give you, an angle projection of 30 degrees. Remember, when you set at any angle of 30 degrees, basically this angle is the level ground, is the angle between the path of the particle and the horizontal surface. So this one is enough to define that this is the angle projection. So it's easy. Calculate the horizontal range. Covered by the particle. We are taking g to be 10 meters per second squared. And this is you can recall, so don't run the value of what? Of G. Not common, but it can happen. That's why McGee is very observant when it comes to getting the information from the first page. You look for all these constants. Is G 10 meters per second squared? Is it 90.81? Is it 90.8? So whatever is given is our G. And therefore, using this information, I must go for the key ideas. What is required? That's what is very, very important. If analyzing the question, what are the key ideas? It's simple. A particle is projected with an initial velocity of 40 meters per second, which means I'm looking at the solution. The solution. This is the solution. What is given? U is given 40 meters per second. What else is given? At any angle of projection, 30 degrees. The angle is given. Angle theta, but even just a theta, it's accepted in physics. It's going to be matter to put the angle. This is theta, 30 degrees. Next, look for any other information given. But see, if I say the horizontal range R, which means R is actually mark. Okay? It's the range required, that's the range required. Then take the G, 9.8 means 10 meters per second squared. So our G is given as 10 meters per second squared. From here, I can as well sketch the given information. By sketching the information, we normally award just one mark. And that mark is very, very important. So we are now looking at the sketch. We are looking at the sketch, and the sketch is all about projecting a particle. And it tells to make us know that this arm is given, that arm is at what? Degrees. And automatically it was given energy at the beginning, kinetic energy, which you translate into velocity, and the velocity is 40 meters per second. Then let us know that what we need is this range, which is R. And this is what we are calculating. Range is not known. H maximum is not required, but you can indicate it. Okay? Can indicate it, but basically we need the range. So this now the sketch we need it to have so that we can, as we do that sketch, can that sketch to get it to require the answer. So there are two ways we can handle this question. So number one, by providing the formula. Number two, you can even use first principles. How to get the range? Range R is equal to speed times time. That's the range. Range is equal to speed times time. So this question, let us now try to answer the particular question you have. So this is R. So our R, if you can recall, we had R. So our R, by formula, is 2 U squared sin theta cos theta divided by t. That's the first expression which we obtained. That was our first expression which we obtained. And we have all those quantities. We have here, use the 40. We have it here. Our angle is given as that. G is 10. You can even condense it as R is equal to U squared sin 2 theta divided by t. I'm now using the second expression after using ignoring. Here it's 2 sine theta, cos theta means sine 2 theta. But even if you use the first one, yes, for my students of sub-math, those are in physics, instead of condensing this level, you can even use this one here, we'll get the same answer. But I'm sure we are done with trigonometry in sub-math. Those who are in principle, when you can do a lot of dimension, you have all that knowledge. So you can either use number 1 or you can use number 2. But number 2 will simplify your knowledge because instead of struggling with the sign and cos at the same time, I'm just having my own theta. So my R will be equal to U is 40. But this time it is U squared, I just square my 40. 40 meters per second, square the 40 here, times sine. One angle is given, but this time we are having a coefficient which is 2 in front of the angle, which means I'm going to multiply my angle by 2. So 2 times the angle, which is 30 degrees. That's what it means here. Divided by the value of G. And G is 10. Have it here. G is 10 meters per second squared, which is 10. Whatever remains is simple arithmetic. So now you get your gadget, and then this answer very fast. Get your calculator and get to the answer. But I'm sure those with calculators, this will give you 1,600 times this sine of now, sine of 60, divided by 10. And that gives you 1,600. Sine of 60, we normally write sine of 60 to fit decimal places. And from your calculator, you place your sine of 60. You get 0.866. Divided by 10. Divided by 10. Then whatever remains, I'm sure you can handle. So this 10, since this multiplication, to just move just increase what? To this one of the zeros up here also. And it becomes 160 times 0.866. This can even move 1 point. What is 1 point? But I'm sure here you get that particular answer. And whatever you are getting now is in meters. Why in meters? Why in meters? It is horizontal range from the scale you have. And the distance, the SI unit for distance is in meters. And that one covers the range. So given in a situation which in fact as the projectile moving vertically upwards at an angle of theta in the horizontal ground. An angle of theta, the horizontal ground. At certain energy, given some energy as U meters per second squared. Then we believe that this R is very, very possible. R is very possible. And our R is given as U squared sine 2 theta over G. Or it is given as U squared sine theta over G. And now we find the value of R. However, this R is not maximum. Remember, we can achieve maximum range, but minimum range is 0. Because we believe somebody can kick a ball from this point of projection, and the ball can land at the same point. More so if you kick it vertically upwards at an angle of 90 degrees, you come back at the same point, which means the distance covered horizontally is what? Is the minimum and is equal to 0. So basically, in physics, we don't ask for minimum range. We only ask for maximum range. And therefore, I'm now taking you to R maximum. When do we claim the distance covered is maximum? And that brings us to maximum range. What's the range? In Uganda here, for those who are interested in soccer, in most cases, if you are training somebody to pick a ball, you can either put an out at a given angle. Just imagine if I can let me begin from this point. If I pick a ball from a point A to a point B. So it's possible to pick a ball from A and last target to B. It's very possible. It's also possible to pick a ball from the same point, land target at C. It's also possible to pick a ball from the same point, land target at D. And it's also possible to pick a ball from what? Land target at E. But this is R1, this is R2, and this is R3, and finally we have R4. So it means R4 exceeds R3, and R3 exceeds R2, and R exceeds R1. And therefore we claim R4 is the greatest range, the maximum range covered by the particle. But this is happening at different angles. It can be theta 1, can be theta 2, can be theta 3, this can be theta 4. So which means not all angles will give you what you want. And it will depend on the situation. Because there is sometimes when you claim that for me 3 plates is soccer, and some people are playing with only 20 minutes, 10 minutes, the goalkeeper will start kicking the ball at an angle which provides for maximum range. So the ball can land here. And just need one more. Just tap the ball in the goal. That means to get maximum range, I must know which angle gives maximum range. That's number one. So the angle is very, very important. The speed must be known. The speed must be known. And that takes us back to R. Our R is equal to d squared sine 2 theta divided by d. So R maximum will depend on the angle, because u or the speed is constant. You already given the particle, the energy, so the speed is constant. So it will be the angle, the which keep on varying. So this angle will determine the maximum range. And for maximum range, this angle must be maximum. Sin theta must be equal to 1. Y1, sin can never exceed 1. Take a note of that. Sin theta or sin 2 theta will range from -1 to +1, and we want the maximum, so we take a 1. That's why this must be equal to 1. And because of that, then our R will equal to u squared. This is now R maximum, R max, u squared times 1, which is sin 2 theta, over g. And that will provide automatically, we are looking at u squared times 1. That gives us R max is equal to u squared divided by divided by what? By D. So R max is equal to U squared over D. And this is the expression for maximum height. This is the expression for maximum height. So remember, when R maximum is required, you never use this expression. We shall be using R max is equal to U squared over D. But if you just need the range, then this is what you use. But if this word is mentioned, if the mention maximum height, maximum range is required, R maximum, then you use U squared over D. I just need to have only the speed from the speed. We just need to have the speed. And it will be there. Then have the speed, and that will be there. When the R maximum is required, speed is equal, so we have the speed, G will be a constant value. Let us have an example. Let us have an example. I believe what we have got today is enough for today. Next time, inshallah, we shall begin from there. I wish you a nice day. And when we meet, we shall see, we shall continue from that point and look at trajectory. We shall look at the trajectory, which will help us to finalize the chapter. At the moment, we are stopping at that point. I wish you a nice day. Assalamu alaikum.